At first glance, this just looks like a simple Python to-do app. But honestly, the real story here isn't about what it does. It's about how it was built. We're going to pull back the curtain on a really powerful methodology that can turn any simple idea into a totally rock-solid piece of software.
So here's the finished product. It's designed to be super clear, right? Every single thing you'd want to do, add a task, delete a task, you get the idea, is right there in a simple numbered menu. This clean interface is exactly what we were aiming for, something that's just intuitive and efficient, right from the terminal.
And check this out. Every action gets an immediate, clear confirmation message. That kind of responsiveness, that feeling of polish, well, that doesn't happen by accident. It's the direct result of a very deliberate, structured approach to building software. And that's really what this is all about.
All right, so let's properly introduce what we're looking at. A simple but really solid to-do app. It handles what developers call the core CRUD operations. That's create, read, update, and delete. Now, keeping it simple is intentional, but making it solid, that's where the real work comes in. And that leads us to the big question, doesn't it? When you're building any piece of software, even something that looks this straightforward, how do you stop it from becoming a buggy, inconsistent mess? How do you guarantee it's going to work exactly as you intended every single time? Well, the secret is a methodology called Spec-Driven Development. And this isn't just a fancy term for writing code. It's about building a blueprint, a rock-solid foundation before you type a single line of Python. So, Spec-Driven Development, or SDD, basically flips the normal coding process on its head. Instead of just jumping in and figuring things out as you go, you first create a detailed specification, a document that outlines every single rule and behavior. The code doesn't lead the way, it just follows the spec. The whole process is incredibly structured. You start with what's called a constitution, which defines the project's big ideas, like the user interface must always be simple. Then you create detailed spec files for each feature, getting into all the nitty-gritty rules. It's only after all that planning that you finally write the code, and then write tests to prove that the code follows the spec perfectly. You know, the best way to think about it is like an architect's blueprint. You wouldn't build a house by just grabbing some wood and nails and hoping for the best, right? You'd start with a detailed plan. The spec, that's the plan for your software. So, let's see how this actually works in practice. We're going to look at how a simple rule written down on paper becomes a real, tangible feature you can actually use. Okay, here's a requirement taken straight out of a spec file. It's a crystal clear, non-negotiable rule. Users cannot create a task with an empty title or description. This isn't just a suggestion. It's a law that the application has to obey. No exceptions. And here's another one, this time focused on the user experience. The spec says that the system has to ask for confirmation before deleting a task. This is to prevent those "oops, I didn't mean to do that" moments, and just makes the app way safer to use. And here we see that rule in action. The spec's requirement to ask for confirmation translates directly into this user prompt on the screen. It's a perfect example of that direct line from the plan to the final product. And that right there is the core power of SDD. Okay, so now that we get the philosophy, let's pop the hood for a second. How does this blueprint-first approach actually influence the structure of the code itself? Well, SSD naturally pushes you toward a really clean architecture like this. You get a clear separation of jobs. Main.py is like the conductor of the orchestra, just directing the flow. UI.py handles everything the user sees and interacts with. And tasks.py is the brain, managing all the actual task logic. Each part has one clear job to do. It really boils down to this. The clarity you create in the spec translates directly into clarity in your code. It just makes sense. If you have a well-defined blueprint, it's a whole lot easier to build a well-structured house. And that brings us to the main takeaway, which is way bigger than just a to-do app. It's about the power of building with intention. It's about designing the what before you ever even think about the how. So why go through all this trouble up front? Because a spec forces your app to behave exactly as you designed it. It helps you create a consistent and positive user experience. It makes your code robust and predictable. And testing becomes so much simpler because you have a clear definition of what working actually means. Plus, it's an amazing way to prevent feature creep, that slow crawl of unplanned features that can totally bloat a project. So the next time you have an idea for a project, you've got a choice. You can jump straight into the code and risk chaos, or you can just pause. Take the time to create the blueprint first, define the rules, define the behavior. Because thinking through the what and the why with that kind of detail makes the how so much more powerful and effective in the end. So you have to ask yourself, what's the blueprint for your next great idea?